Unit 1, Model of the Atom, Size and Mass of Atoms. Atoms are very, very small. They have a radius of 0.1 nanometers, which is the same as saying 1 times 10 to the minus 10 meters. A nucleus, being in the centre of the atom, is even smaller. It is 1/10,000th of the size of the atom, which is the equivalent of 1 times 10 to the minus 14 meters. Despite being so small, almost all of the mass of an atom is in the nucleus. This is because protons have a relative mass of 1, neutrons have a relative mass of 1, and in comparison, electrons have a relative mass that is very small. One of the facts about an atom that we use is called the mass number. The mass number of the atom is equal to the sum of all of the protons and all of the neutrons in the atom. Atoms of the same element will always have the same number of protons, because it is the number of protons that defines an element. They can, however, have different numbers of neutrons. If you have two atoms of an element and they have different numbers of neutrons, these are called isotopes. So the definition of the word isotope is atoms of the same element with different numbers of neutrons. If you look on the periodic table, you can see a symbol for an atom. For example, if you look lithium up, you will see this symbol. Now the good news is, on the periodic table, they will give you a key. They will tell you that the top number of any symbol is the mass number, and that the bottom number of any symbol is the atomic number. They even tell you in brackets, so that you don't have to remember it, that the atomic number is also called the proton number. So if we take the atom lithium as I've written it there, we can tell by looking at the bottom number that lithium has 3 protons. As we said earlier in this video, in order for an atom to not have any charge overall, the number of protons and the number of electrons in an atom must be equal. So if we've used the atomic number to tell us the number of protons is 3, we can also use the atomic number to tell us the number of electrons is 3. Because the mass number is equal to the protons added to the neutrons, we can work out the neutrons by doing a simple take-away sum. Neutrons equals the mass number minus the protons. So for this atom, the neutrons would be 7, take away 3, which equals 4. The number of protons, neutrons and electrons in an atom is a really easy question for the examiners to ask. So for that reason, I'm going to go through a couple more examples. And the one that I'm going to start with is the one that students often find tricky. Hydrogen. The atomic number of hydrogen is 1. Therefore, hydrogen has 1 proton. Because in an atom the number of protons equals the number of electrons, hydrogen has 1 electron. At this stage, students often make a mistake and write down that hydrogen has 1 neutron, but you've got to follow the rules. The number of neutrons equals the mass number, which is 1, take away the atomic number, which is 1, which gives you 0. Let's look at another example. This time we'll do oxygen. The atomic number is 8, so therefore it has 8 protons. Because protons equal electrons in an atom, it has 8 electrons. And in this case, the mass number, take away the atomic number, also gives us 8. In the exam, a lot of students who forget what they're doing will just guess what the number of neutrons are, or they will write the top number. The trick is just to try and stay calm and remember the rules. So for a final example, if we look at potassium, the proton number, the atomic number is 19, so potassium has 19 protons. Because it's an atom, it will therefore have 19 electrons. The neutrons is going to be the mass number, take away the proton number, which gives us 20. So how can they make this hard? The way they make this hard is by giving you ions to do instead. You still need to look at the periodic table and find the mass number and the proton number. You can write down that the number of protons is 8. Because if it wasn't 8, it wouldn't be oxygen. You can write down that the number of neutrons is still 16, take away 8, which is 8. It's the number of electrons that is affected when an atom turns into an ion. In this case, an oxygen atom would have 8, but because it has a 2- charge, that means it has 2 more negative electrons than the atom would. So therefore, it has 10 electrons. If we look at a positive ion and look at sodium, again, because it's sodium, all sodiums, whether they're atoms or ions, have 11 protons. In this particular case, because the mass number is 23, that means that sodium has 12 neutrons. In order to work out the electrons, we start off with the number that the atom would have. Because it's got a single unbalanced positive charge, that tells you that it's got 1 less electron than it should have. So therefore, the number of electrons in a sodium ion is 10.